be. So this is lowercase p, which is 280 minus 0.4x. So this is the price per unit. So obviously, we know that the revenue, uppercase R, must be price times the number of units. So it will be all this. I don't know what they're asking, but I just want to make a point. So this must be the formula or the function called revenue. Price times the number of units sold. It also determines the total cost. So they are giving us the total cost, which is 5,000 plus 0.6x squared. Find the total revenue. Okay, I didn't even read ahead. So obviously so we know that. So this is negative 0.4x squared plus 280x. I thought about it because it says the title is maximizing profit. So obviously we need revenue and cost in order to even talk about profit. Okay, find the total profit. That's part B. So the profit will be the revenue minus the cost. So let's write it first like this. And then copy the revenue, negative 0.4x squared plus 280x. But careful, we have to subtract this. Minus 0.6x squared and minus 5,000. So this with this will be negative x squared. Then 280x will stay, and then minus 5,000. So that was part B. Part C, how many refrigerators must the company produce and sell to maximize profit? So now when we talk about maximizing profit, then I have to find P prime, which will be negative 2x plus 280. And we have to set it equal to 0 to find critical numbers. You can say, I don't need calculus for this because I know this function is quadratic and I know how to find its maximum without your calculus things. But this is what we need to do. Okay, so obviously when I set this equal to 0, I get 140 units. So this is the price per unit based on x, and x is the number of units. Maybe I should mention this. Units, or number of units. Okay, so I know that this, because of the negative and the fact that it's a quadratic function with a maximum, but I cannot use that in calculus. I have to show why. Although I'm happy if you just say that. It's, obvious, right? But here's how we do it normally for other functions. We have to study the sign of p prime. So 0 to infinity, which we know it's not possible. We're not talking about infinite number of units. But 140 is 0. And just plug in 0. When you plug in 0, you get a negative number, right? And to the, I'm talking about here. Sorry. When you plug in a 0, you get a positive number. And beyond that, of course, this is a linear function. It looks like this, coming from positive, going negative. So this is good enough. So you know that this is the maximum. Now, if I want to find the profit that is the maximum, I have to go back to the profit function and plug in 140. So then I have 140 squared plus 280 times 140 and minus 5,000. So let's see what we get. Careful how you plug all this in. 140 squared plus 280 times 140 and minus 5,000. I'm checking all my numbers. Yes, that's correct. Plus 280. Yes, that's correct. That's correct. So the profit is 14,600, and that is guaranteed to be maximum. If we produce 130 or if we produce 150, we're not going to get a maximum. Only when we produce and sell 140. That was part C, and I think there is part D. What is the maximum profit? Okay, that is part D. And part E, what price per refrigerator must be charged in order to maximize profit? Okay, so now I have to go back to the price. And this is the price per unit. So I have to plug in here 140, 280 minus 0.4 times 140. So that's part E. So price per unit That's the P. And 280 minus 0.4 multiplied by 140. And what is that? 280 minus 0.4 times 140. I got, that's not possible because I did not type in correctly, punched in correctly. Okay, so 224 per unit. I didn't say anything. I realized that you were gone, or I was gone. Okay. Any questions? Is this okay? Is this what you meant?
Yeah, that was okay. Thank you.
Thank you. Anything else? Other questions?
On the same page, can we choose one of the maximizing volumes? I don't think we did number 18. Can I do that one?
Okay, so let's take a look. Okay, so let's look at 18 on the same page. So let's read it. I hope you want me to share my screen? Do you want me to bring up the book, or do you all have it? So I'm assuming that that's okay. Okay. From a 50 by 50 sheet of aluminum, and they are in centimeters. Okay. Square corners are cut out so that the sides can be folded up to make a box. Okay, so we know how, I'm just looking for any piece of paper. So I just put it in the recycling bin. So this is a square, right? So we know that this is a square piece of aluminum. Well, so imagine that this is 50 by 50. And now I remove squared corners from each. See why we do what we do in kindergarten? Okay, so now I will fold the sides and I get a box. Yes, it's stretching it, I know. But this is what they're asking us to do. Good. So the sides can be folded up to make a box. What dimensions will yield a box of maximum volume? Okay, so this is how the box will look like. It says to fold squares, but I don't know how deep should this be, how big should, so I'm going to just say that this is the height. Obviously, because I removed age and age from all corners, right? So maybe I should take this back. So this is age and this is age, right? And this is age and this is age. So which means that the length now of the box is what it was initially, which is 50, minus twice age. So this is 50 minus twice age. This is 50 minus twice age. So then the base, 50 minus twice age, the same thing here, 50 minus twice age. Now, they want us to determine the dimensions that will yield a box of a maximum volume, and what is the maximum volume. Now, let me put this aside because it's in the way. Good. Perfect. So then the volume of this box will be area of the base times the height. So area of the base is 50 minus 2h times 50 minus 2h multiplied by the height. We know how to multiply or how to square binomial. We've known that from the very beginning of the class. So I square this minus 2 times the first times the second plus the second term squared. And then I distribute h. Now, the question is, if I want to do that, because I need to differentiate. We can do it, it doesn't matter. We can do it without, or we can do it expanding. It doesn't matter. Okay, so 50, so this is 25 squared with 2 zeros. I mean 5 squared, which is 25, and 2 0, minus 2 times 2 is 4. 4 times 50 is 200h, and plus 4h squared, and multiplied by h. And now I will distribute h, present everything in descending order. So 4h to the third minus 200h squared and plus 2500h. So let's stop and see if we have questions so far before we continue. Is this okay so far? Anyone?
Yeah, I'm good so far.
Okay, so now we have the function and we want to maximize it. Every time we talk about max min, we have to discuss the derivative. So v prime of h will be 12h squared minus 400h plus 2500. I have to determine v prime of h, solve the equation v prime of h equals 0. And I have 12h squared minus 400h and plus 2500. You can plug it in directly in the calculator. I'm fine with that. In calculus, I'm assuming that you remember how to solve a quadratic equation using the quadratic formula. So I'm going to share my screen and just go directly to solve this quickly. So in apps, we want this polynomial. So number 9, it doesn't matter. I think I just passed it. Or just press 9. So it's a polynomial. Is degree 2? Yes. Yes. Okay. Leading coefficient is 12. Next coefficient is negative 400. The next coefficient, no, I didn't mean that. Why is this rushing? It's good that the two coefficients will not disappear. I just have to go to the third one. Okay, 2500. Good, so now I want to solve, and I get x, well, in our case it's age. Age equals 25 divided by 3, or age equals 25. Age equals 25 makes absolutely no sense. Algebraically, it's correct. There is no doubt about it. But it makes no sense because I'm going back to my box. This whole thing is 50. This cannot be 25, right? So it will be 25 like this. So I will not have a box. So although algebraically this is correct, centimeters, it makes no sense for what we are looking at. So the length and the width will be 20, what was it, 50 minus 2 times 25 over 3. And the height will be 25 over 3 centimeters. So what is this? 50 minus 50, so it's 50 times 2/3. So 100 divided by 3 centimeters. But now, this is not good enough. I already assumed that this gives a maximum. No, I cannot. I cannot assume that it gives a maximum. I have to put 0. Okay, of course, it's not infinity. You know what I mean? 25 divided by 3. So when I plug in 0, I see it's positive. And when I plug in, let's say, 100, 12, what do I get? 12, 120,000, but with this 100 would be, so minus 400. Okay, so plus 2,500. So you see, so this is it has to be negative. So I'm just trying to see how I can show you, or I just plug it in the calculator. And so that is, I said 100, yes. 100 squared minus 400 times 100 plus 250. I'm getting something. Yes, yes, that's why. Because yes, I cannot be into 100. So 25 is also 0. So I can only pick a number between 25 thirds and 25, because this is the other solution. Okay, so I can only plug in 20 if you want. So 12 times 20 squared minus 400 times 20 and plus 2,500. This has to be a negative number, guaranteed. Well, I mean, that's a quadratic function, so it's negative between solutions. So this indeed will give a maximum, increasing, decreasing. And if I am asked to determine the volume that is maximum, I have to plug in 25 over 3. And where was my function? Oh, so here's the function. So I have 50. I already have determined the length and the width, so that's even better. So 100 divided by 3, which is squared. So this is the length and the width, right? Multiplied by h, which is 25 divided by 3. And that will be the maximum. So 100 squared times 25, and I divide by 9 times 3, which is 27. So it will be 9259.26, of course, cubic centimeters.